Dr. Ravi K. Naitam, scientist NBSS and LUP ICAR Nagpur, delivering his expert talk on application of high-resolution satellite data for soil resource mapping. He has previously worked as scientist at National Academy of Agricultural Research and Management ICAR Hyderabad. He received Zonal Award of Indian Society of Soil Science for the West Zone in 2002. I welcome you, sir.
Good afternoon, all. First of all, I'm highly thankful to the organizer for giving me an opportunity to present my work here. And the topic of my talk is the application of high-resolution satellite data for soil resource mapping. As we all know that land is a very broad concept, and soil is one of the part of it. So soil is a naturally occurring body that has been evolved due to combined influence of climate and organism acting on parent material conditioned by relief over a period of time. So nowadays, soil maps have become valuable tool for natural resource management because the adequate knowledge about the properties and distribution of soil is a key issue to support sustainable land management, which among these some issues are erosion control, fertility management, crop choices, possibilities for irrigation, environmental monitoring and modeling. With the great explosion in computation and information technology, the vast amount of data and tools in all fields. So soil science is not an exception. So with the ongoing creation of regional, national, continental and worldwide database, soil science has also such application in the application of this space data. So increasing powers of tools such as GIS, GPS, remote sensing data and other data from sensors, such provided by the DAME. Nowadays, the digital elevation model is one of the most important thing for this soil mapping. So since if we see the beginning of soil survey in India, so the soil maps are prepared at various scales, some small scale, medium scale and large scale as per the requirement of the user agency. So the conventional soil surveys in the earlier days, we people were depend on the conventional soil surveys. So the convention, though these surveys provide such information, but they are cumbersome, time consuming and high intensity. So remotely sensed data has proved to be a valuable tool in soil resource mapping due to various advantages. Some of the advantages are the larger synoptic view, coverage of inaccessible areas. In case of conventional survey, we could not be accessible to some mountainous, swampy and other thick forest areas. So here it is the benefit of this remotely sensed data. And another is that multispectral and multitemporal sensing capabilities of the space-based sensors are well suited to inventorying natural resources. The remote sensing data from space-bound sensors like Landsat, SPOT, IRS list 1, 2, list 4, and AVIS. So nowadays, with this help of this, the soil surveys are made from 1:250,000 scale to 1:50,000 scale, and nowadays this is a time for large scale soil mapping. So such kind of data is available for the agencies, those who are engaged in preparation of various soil resource mapping. So soil resource inventory is nothing but it is only a soil survey. So soil survey is essentially the study and mapping of soils in the natural environment. So it is the systematic examination, description, classification, mapping of soils of an area. So it is a multi-step process, and so some of the activities you are seeing here on the screen. While doing survey, we have to move to the field and dig the profile, and after digging the profile, we have to record the morphological characteristics of soils in the field as well as some land characteristics near about the profiles, and then we have to bring the samples in the laboratory, analyze it. So what is the need of soil survey? So the need of soil survey is to avoid the disappointment and make optimum use of our limited resources. For that, we must have an in-depth knowledge about different soils, their morphology, characterization, behavior, kind and degree of problems, and their extent and distribution on the landscape. And this can be achieved through only soil survey and mapping. The scale of mapping will, however, depend on the purpose and terrain of kind. Basically, the soil surveys are taken with some its own objective. The soil surveys are taken. The soil surveys have two objective. One is fundamental. In case of fundamental objectives, it helps in gathering the information about the properties, especially genesis and classification of soils. So that is pedagogical work. And in case of applied soil survey, the applied aspect in soil survey includes the interpretation of soil survey data for various uses like agriculture, forestry, pasture development, recreational, and other purposes. So different types of soil survey, there are different types of soil survey, and that depends on this objective, method, type of base map use, type of map unit, intensity of survey. So these types of survey depend on these parameters. Basically, there are five types of soil survey. One is reconciled soil survey, detailed soil survey, detailed reconciled soil survey, semi-detailed survey, rapid reconciled survey, and exploratory survey. So the methodology of survey is same, but the material required and the number of observations, frequency of observation, that decide, and the purpose that decide the type of survey. Such as the reconciled soil survey are taken for large areas, whereas the detailed soil survey are taken for the priority areas. Just and for this purpose, for this purpose, the scale of soil survey is most important. In case of reconciled soil survey, the scale of soil survey is very small. On the other hand, the scale of detailed soil survey is very large. Nowadays, the surveys are took place at the scale of 10,000 to 5,000 level. So soil survey is a multi-step process, and it involves fieldwork to study the important characteristics of soils and associated land features, laboratory analysis to supplement the field observation. After the field observation and analysis, there is correlation and classification of soils into taxonomic classes, mapping of soils to establish and draw some boundaries of different kinds of soil on standard topographical maps. Soil survey interpretation makes the prediction about the potential of the different potential for different alternate uses, and it helps to transfer the agrotechnology from research station to farmers. Now, the standard survey is normally carried out in different mapping levels depending on the requirement of the area. Just as earlier I said that the soil surveys are taken on the basis of their purpose. So, in case of reconciled soil survey, the scale is very small, just like 1:250,000. Accordingly, we have to use this space data. In case of reconciled survey, normally we use list 1, list 2, and obvious data. In case of semi-detailed soil survey, we use normally list 3 data. And this reconciled soil survey takes place for country level. In case of semi-detailed soil survey, this kind of survey that takes place for areas like district level. On the contrary, detailed soil survey are taken for this very small area, and in that case, we need very high resolution data. The satellite data which is having very fine resolution, the fine resolution. In case for that, normally we use ResourceSat, list 4 merge data, and Cartosat 1 and 2. So while moving to the field, the surveyor has some its own concept, because in everywhere soil landscape model captures the relationship between the soil in the area and the different landscape. It means that in every landscape, the landform soil relationship is different. So the surveyor detects different soil formative environments. As I said that soil is a function of multifactor. The Jenny has given some model of soil formation, that is S is a function of CLOPT. So accordingly, when the surveyor moves to the field, he detects different soil formative environment through visual interpretation of geological map, topographical map, satellite images. The spatial extent of the soil formative environments are then used to delineate the landforms, and that landforms further useful in physiographic unit delineation. The physiographic units are based on the relationship between the environmental condition and the soil mapping units. Physiography is nothing but the comprehensive study of surface form, geology, climate, soils, water, and vegetation, and their interrelationship interactions. The factor involved in the physiographic processes. Just I said that soil is a function of these 5 factors, and in addition to that, there are some soil farming processes. In every region, all the soil farming factors are present, but the dominance of process may be different. So accordingly, the soils vary from region to region. Nowadays, traditionally, remote sensing imagery has been used to support segmentation of landscape into different. The accuracy of soil map largely depend on how precisely and accurately the landform units are delineated. It means that this thing is very important. In case of soil survey and soil mapping, before to map the soils, we use the base map. In case of base map, we prepare the base map from integration of various data, just like your satellite data, topo sheet, topographical sheets, and some nowadays the detailed surveys are took place at some farm level. So for that, the accuracy of the survey is totally depend on the accuracy of delineation of landforms. So with the increasing availability of digital elevation model, a surface is parameterized by attributes such as, once we have the availability of digital elevation model, from that DEM we can extract slope, accept plan, profile curvature, flow accumulation, and to obtain the relief of surface of topography units. So these things helps us to delineate the landform exactly. The elevation information available in the Survey of India topo sheet and some coarse resolution data is inadequate. Nowadays, when we are moving for a detailed soil survey, we need some high resolution digital elevation model that helps us to delineate the landforms precisely. Relationship of scale of soil map and frequency of field observation. As I said that in case of rapid reconstruction soil survey, the frequency of observation will be 1 in 10,000 hectare. In case of reconstruct soil survey, the intensity 1 in 625 hectares or 1 in 100 hectares. In case of semi-detailed soil survey, where the scale of map is 1 is to 50,000, so the observation will be 1 in 25 hectares. On the other hand, in case of detailed soil survey, the frequency of observation is more. In case of low intensity detailed soil survey, the intensity of observation will be one sampling point means profile per hectare, and in case of high intensity detailed soil survey, the frequency of observation will be 4 per hectare. Similarly, these different kinds of survey, while doing different kinds of survey, we must have to delineate the boundaries on the map. So that is the most important and critical thing while preparing the map. In case of rapid reconstruction soil survey, the boundaries are plotted by interpretation of remotely sensed data. In this kind of survey, we cannot traverse the area full. So that's why it is only the option to delineate the boundaries of these units as per the interpretation of remotely sensed data. In case of the reconstruction soil survey, again the boundaries are delineated by the interpretation of remotely sensed data, and some patches you can verify by traversing randomly. In case of semi-detailed soil survey, the boundaries in delineation samples are identified by actual traversing. Means in case of semi-detailed survey, the boundaries are identified. Most of the boundaries are identified and verified by actual traversing, and some whenever there is some complex or you can say inaccessible area, in that case you can take the help of remotely sensed data. However, in case of detailed soil survey, all the boundaries are checked by the actual physical traversing. So this is about the some background information of the survey. Now, as far as the NBSS LUP is concerned, prior to that, in our country we do not have such a perfect and some taxonomical soil map in our country. So the establishment of this bureau takes place uh, only for to prepare the detailed soil survey map of the country. And the philosophy of generating soil map of a country on uniform method was put forth in first national workshop on soil map of India held at Nagpur in 1986. And it is this, and in that workshop, it was decided that the soil resource map of all the states will be prepared on 1 to 250,000 scale. On the other hand, the soil map of Union Territory will be prepared on 1 to 50,000 scale. So while doing this, while preparing the soil map of India, we followed the three-tier approach, that is field survey and mapping, soil analysis, cartography, and printing. This is a three-tier approach. So this is the methodology we followed in this preparation of soil survey map, collection of satellite data, other ancillary data, georeferencing, and ultimately the preparation of soil map. And after preparation of the soil map, each map unit was evaluated for its suitability, land capability, and other purposes. So that is called, that comes under land evaluation. So while preparing the soil map India on 1:1 million scale, the total geographical area of the country is 329 million hectares. The number of topobase used were 394, number of satellite images were 176, number of field parties were 150, manpower 1500, and the period it is almost 10 years. And the number of samples is 100,860, and the number of soil profiles were studied in the whole program were 75,400, and the number of samples were 9,250. So after doing all these things, we prepared the soil map at the subgroup level, and the mapping units are 1,649 for the country. And after that, it is concluded that in our India, out of the 12 soil order, we have only 7 soil orders. So this is the soil map of India. And this, for preparation of this best map, the delineation of landforms were delineated using Landsat and Spot in conjunction with the Survey of India topo sheets. After this country level, if we will move to the district level, so this is the map of Yavatmal district. This map was generated using the list 3 data, and that time such fine resolution data were not available. So that's why for this semi-detailed survey, only list 3 was the option. So in that case, for big regions, these maps were prepared through association of soil series. This is the soil series association map, and this map was prepared some 20 years, 15 to 20 years back. And recently, the same district we have covered through the using high resolution soil data. So while preparing the land pump, if you will compare the land pump generated through this list 3 and just recently list 4 data, you can find the differences in the landform delineation. So that is the ultimate use of this fine resolution data. Similarly, this is the list 3 data of Nagpur district, which is having some coarse resolution than the nowadays data. So this is the soil map of this district, which is up to subgroup level. So if the scale of map is smaller, the information, the details of the area will be less. And if your data will be fine resolution, the information will be more. So we have seen the state, country level, district level. Now this is the watershed level data. First, to study the watershed data, we have used this pan data, and this data was merged with the cartoset 1. And so after merging this is the methodology used for the preparation of base map and soil map, and this is this physiography land use unit map. So after this, if you will see the physiography and land use units, you can see land use units that was integrated with the SRTM 30-meter data, and the landform were delineated using this integration of these 2 data. And so on that basis, we have carved out the land use land cover. So in this block, and this is test in this block, at block level, approximately 50% area of the block is double crop area, and 20%, 21% is single crop area. This area is well known for its sugarcane production. Now, after the delineation of land use land cover, we have delineated the landform. So in this block, we have identified 13 different types of landform, and these different landforms, if you see here, this is the higher part, this is the plateau part of this, and if you will look at this region, this is the low-lying area. So according on that basis, and after the field soil survey, correlation and analysis, the soils of the districts were studied and correlated, and in that district 20 soil series, in that block, in that tehsil, 20 soil series have been identified. And now the most interesting thing is that, as I said, that if if you will look this landform soil relationship in the tehsil, if you look at here, you can see here linear ridge, scarp slope, plateau. So this is the elevated portion. So in that portion, if you will see the soil depth, this is the pH and the altitude of this soils. You can find here with the increasing depth in that area, this area is intensively cultivated for sugarcane, and there is high good availability of irrigation water. So sugarcane fields are whole year under cultivation. So in this area, if you move from top to top, the pH of the soil increases, and this pH of the soil increases also increase shows the increase in the exchangeable sodium percentage. Means the sodification of the soils increases with the depth and this altitude. Similarly, as I said that, similarly, this is the case study, just I have conducted the case study for this Yavatmal whole district. So in this case, we have used SRTM 30-meter dam, then Sentinel data, integration of this, carve out this landform. In this, we have found 13 landform. So if you compare the landform delineation of this district by list 3 and this Sentinel 2, so there is much variation in this landform. So this is the actual utility of high resolution data in our studies. So if the base map, if the delineation of landforms are correct, precise, then only your soil data and soil survey interpretation, soil survey reports will be good, and that will be applicable and useful for the farmers. Otherwise, it will not be so good. We can't suggest a proper land use plan to the farmers. As I said that on the basis of delineation of landform, earlier this Yavatmal district was very famous for the production of cotton, but nowadays due to climate change, erratic rainfall distribution, this district becomes hotspot of Maharashtra, and the productivity of the district is very low. So after the survey, we have prepared the soil depth map. So in this case, you can see that the soils are divided into 6 classes. So see, so most of the soils of the area falls under type 1. So this type 1 is nothing but the shallow soils, because most of this region is comes under hills, ridges, and plateau. Only very few area comes under this good quality soils, because cotton is a very deep rooted crops which needs deep soils. So that's why soil depth is another one factor, and this irrigation availability is another factor because behind the declination of the productivity of this district. And again in this district, so this is landform soil relationship. So these are the soils of valley plain which are found in the lower altitude. So that's why the slope of the area is 0 to 1%, and the soil development of soil is better than this upper area. So in this case, the soils are very deep, and these soils are classified as typical haplostate vertisoils, typically known as black cotton soils, which are used for the cultivation of cotton. On the other hand, these are the soils of upland. You can see here soil depth, and these soils are shallow, and such soils are not high. I mean, I didn't say that is not suitable, but these are not highly suitable. If you match the requirements of the crops, these soils fall under moderate or marginally suitable. So that's why the productivity of these soils is low compared to the deep soils. And another thing is that these, if you will look at see the structure and soils, the water holding capacity of these soils is also low. On the other hand, these deep black soils have good water holding capacity. In the rainfed conditions also, these soils can provide good moisture to the cotton crops. Again, these are the soils of the plateau. Plateau is a top portion, so there is no much soil development. That's why the soils are shallow in this region. These are the soils of the pediments. Most of the area of this district comes under hills, ridges, and some isolated hillocks and plateau. However, some pediments have some very deep soils, but here you are seeing the some white patches. This is nothing but the only accumulation of calcium carbonate in the potted crop. Similarly, the application of space data is we have tried for this village level. So this is Khapri is one of the village of Nagpur district. So in this case, we have used list for data, 5.8 meter resolution. Again, integration with DEM, cartosat DEM. We have prepared the land use land cover. So you can see here. So these are these low lying. These are the low lying areas having good vegetation. On the other hand, these are these high altitude areas which shows which doesn't show this good land use land cover. So in case of here, if you will see here, this green color indicate double crop. On the other hand, this area shows the degraded forest. Now, from the dam we have prepared the slope map. The slope of the area varies from 1.3 to more than 15%. However, this most of the area having green color falls under very gently sloping, means 1 to 3% slope. Now, this integration of this DEM and satellite data, we have delineated the landform. So landform is nothing but the physiography. So landform delineation indicate that here are some isolated hillocks, plateau, and this green area, green region indicates the valley region. Now, after that, after the study of soils in the field, those were correlated and soil map is prepared at the level of series level, mono series level. As earlier we have seen this in case of list 3 and other course resolution data, the soils were mapped at the association level. But in case of this high resolution data, means application of high resolution data helps us to map the soil at detail level. So this is a detailed kind of survey. So in this village, we have identified 7 series, and this on the basis of this 8 series, on the basis of this green color is soils have very deep and good soils. And these soils, after that, the soil map is prepared. The mapping units were evaluated for its capability. So according to the slope and other parameters, depth, the capability of the each unit was evaluated, and the only very few soils falls under capability class 2 and 3, and most of the soils falls under 4 and above. So according to the land capability classification, the arable soils are very few and other soils are more. Similarly, when we do soil survey, the purpose of soil survey is different. So in case of this land irrigability classification, we study the behavior of the soils under the altered soil moisture regime. Means once the irrigation is introduced in the new area, so how the soil behaves with irrigation. So this kind of studies takes place in this land irrigability classification, and most of these studies takes place in canal and command area. So this proves that most of our soils are falls under the land irrigability class 2 and 3. Now, again, the Nagpur region is also famous for cotton cultivation. So, but if you evaluate the each and every unit of this village, means what we used to do in this case, we match the requirement of the cotton crop with the qualities available with your soil. So in this cotton suitability map, only very few soils are marginal to moderately suitable. Most of the soils are not suitable for cotton because cotton is deep rooted crop, and most of the area is under high altitude, some hillocks and plateaus and all these things. So that's why the soil depth is a limiting factor in this region. Similarly, evaluated for the suitability of soybean. Soybean also is one of the major crop in this region. So if you will look at the soybean is a shallow rooted crop, and so for that purpose, the requirements of cotton crop is soybean crops are different than the requirement of soybean crops are differ than the cotton. So that's why if you look at the map, the quite good amount of area is suitable for the moderately suitable. However, this most of the area which falls under hills, ridges and plateaus is not suitable because of the soil depth, and you can say stoniness, and all these factors are the constant for the suitability of cotton in this region, suitability of soybean in this region. Therefore, very few area is moderately suitable, not highly also, moderately suitable for the soybean. So after studying this kind of soils, we have to suggest the land use plan to the farmers, or you can say planner agencies. So this is one of my study which I have conducted in this Udaipur, when I was posted in Udaipur, Rajasthan. So this study comprises the Aravalli, part of Aravalli Hills, and most 100% area is under the Aravalli Hills. So in that region, most of the area is under for degraded forest, but some patches are cultivated, patches along the streams, or you can say valley, are used for cultivation of this some local crop, just like maize, some very few wheat, and very few rice also. So maize is the major crop in this region. So after evaluating all the constant, after studying all the constant and potential of this land, we have suggested them some suggested land use, just like silviculture, agroforestry, afforestation in case of degraded areas, and the area which is quite good nearby the valleys and having slope very nearly level to gentle slope, these were allocated for the double cropping with the provision of irrigation. And very few areas at this bottom, at the mouth of this watershed, which has ample availability of water for irrigation, these are suggested for the intensive cropping. So this is about the studies, application of the remote sensing data in soil studies. And from these studies, we can conclude that extensive and reliable information on soil and land resources are prerequisite for effective and efficient management of and planning of natural resources. High resolution satellite data will be of immense help in precise and faster mapping of soils as compared to the conventional method. It is about me. Thank you.